So we're going to be able to look at these and describe these transformations. Uh-oh, what did I do? Okay. We're going to be able to look at similar shapes by looking at the transformation itself. In this case, it's a reflection. A reflection on what? On y-axis. So we do want to be able to describe these transformations, reflections, dilations, rotations by the operation that we can get it from. So if I were to give you this on a paper, can you create that same image? Okay, and that's what this is the whole idea by confirming similarities. Again, it has the same shape, but not the same size necessarily. Okay, all congruent shapes are similar, but not all similar shapes are congruent. Does that kind of make sense? All thumbs are fingers, but not all thumbs are, right? Is that the same?
All thumbs are fingers, but not all fingers are thumbs.
Yes. So trying to think of. Okay, here we go. This is a part that we're going to look at. Okay, this is one right below it. Now, I want to be able to provide you guys the way to describe these things. We're not going to look at the transformation notation of these. We should be able to identify them, but we don't necessarily need to. But what we're going to look at here is we're going to look at how to describe these transformations when we're creating our homework. On the test, you will have some questions like these, and I think if I can get through this, we'll have no homework today. You'll have only one problem to do, and we'll just practice these tomorrow. That's what we're going to practice tomorrow. I figure if we can do that, we're golden, man. We're golden. Now, let's look at the traditional ones that we did last year. Whenever we talked about transformations, the transformations that you guys did, the first one was a translation. And we referred to translation as a slide. So it's sliding over. The notation you guys have seen the most of, the mathematical notation for this, was x comma y. And you're going to look at x plus or minus a, y plus or minus b, and the way that we kind of vocalize these and the way that we say these is we say translated by or translated by right / left plus or minus a units, whatever that happens to be, by up or down by plus or minus b. So that's how we're going to describe it. Oh, it tells us to translate it. Oh, we're going to translate it over by 3, down by 2, by -2. We're going to translate it over 6, right to the 6, up by 5. That's how we're going to describe these. And as long as you're able to describe the translation that's being applied, I'm okay with you guys giving me those explanations. You guys don't need to give me this mathematical notation for a translated figure, okay? The next one that we're going to do here, what was another one we talked about? How about that? Awesome. Reflection. A reflection is implied by a flip. This should be review for you guys. We didn't teach you guys this, but you could see it again if you have notations like this. A x comma y in which you get a reflection of negative x comma y is considered y-axis flipped. And our other version we refer to as x comma y, in which we're going to get x comma negative y is an x-axis. And all I'm looking for you guys to do is just describe the basic for these. Do you need to give me these? No. But if you, this is what the notation looks like it mathematically. All I'm looking for is the several things to tell me it's a reflection. God, I keep on spelling reflection wrong. On x/y-axis. That's all I'm looking for. Whatever that donation, whatever that denotes, whatever that happens to be, I want you guys to be able to provide me this information. The next type of one, what was the final one we did last year? Rotation. A rotation, let's look at, let's do red. Is a spin. And I'm not going to give you the notation for this because I'm not going to, you guys are going to not really do that many. I can provide you them, but it's going to be 90, 180, 3, it's a lot. It's too much. So I'm not going to provide you guys to them. But all we're going to look at here is we're going to say rotation. Rotation by whatever degrees. So I'm going to say just degrees. Which are the ones that we focused on the most of? 90, 180. We also, my kids did what else? 270 and 360. Those are the basic forms we can because the standard position of our line can be rotated easily that way. I never gave you guys like a 45-degree counter rotation on these, okay? And then we also want to refer to them as what direction? What do we call those directions? Clockwise or counterclockwise. Beautiful. Basic form of them, that's it. What is the newest one we can kind of introduce that we've introduced to it? What's the final one we just did? Dilations. The dilation is the last one we can put with all these different types of transformations. Before we even do dilations, all these figures would be congruent. Same shape, same size. The second we add a transformation like a dilation, they become similar because they're no longer the same shape and size. They're the same shape, but not the same size. So we say dilation. And we got to refer to several things, and it depends, and we're going to kind of dig more into this tomorrow. We got to refer to several things. Enlargement, or a reduction. It's a dilation, a reduction by what? Okay. Then we also need to refer to the scale factor. It's reducing down by 1/2. It is increasing its size or enlarging by 4. Okay. The last thing we also want to imply in case we use it, which we will tomorrow, this is going to be probably the most hardest part we're going to do tomorrow, is the center of origin. Origin. And these are the things we have to imply when we talk about these. For the rotation, I'm just going to give you them just in case you guys want them. 90 degrees would be x comma y. Clockwise would make it, I believe it's switched, yx. No, I'm not going to give you them. Let's not give you them. Let's not give you them. I don't want to teach you the wrong thing. Yeah, let's not give you those. Okay, so this is what we want to be able to describe when using these type of transformations. Before we even describe them, let's just apply what they mean. What does it mean to be similar? So let's go ahead and try the next ones out. Do me a favor and copy down this problem. Performing a similar transformation. This is also referred to as applying a sequence of transformations. We're going to have three pictures on this graph, and we got to be able to determine what the picture looks like and what our final image is. Because it's giving us a pre-image of A, B, and C, and it's telling us to do two different types of transformations. What are those two transformations? A translation, then a dilation. So we're going to do one after the other. Just read it like a book. Go from the top of the list down to the bottom of the list. Okay? And we're going to do just that. Graph A, B, and C, and its image after the similarity transformation. Majority of the time, we are going to probably have some form of dilation in there, because if it wasn't, this would just be a sequence of transformations. So we're focusing on dilation, so let's focus on a lot of doing these similarity transformations. First thing we got to do is I want you guys to plot A, B, and C. Practice that. This is just extra practice on practicing points. That's our first step, and always going to be our first step, is we want to be able to practice and look at where our first steps are. So I'm going to graph these A, B, and C. Tells me I'm going to go back 4, up 1. This is A. I'm going to go back 2, up 2. This is B. And then my C is going to go back 2, up 1. Tiny little triangle. Looking at this next one, the first thing we want to be able to do is apply the first transformation. Our first transformation happens to be a translation. What is our translation telling us to do with every single one of those points? Add 5 to x or add 1 to y. What's another way we could say that? It would be able to say go right by what? And then up by what? Could show that too. That would be a written explanation if we wanted to. We're going to translate this figure right by 5 units, up by 1. So do me a favor and translate those. We're going to look at translating this image. We're going to translate it over 5, up 1 to every single one of my points. So over 5, I'm going to start with B, 1, 2, 3, 4, 5, up 1. This is B prime. My first set of points. Over 5, up 1 gives me C. Over 5, 1, 2, 3, 4, 5, up 1 gives me A. All I did is I did my first transformation. Let's go ahead and write out those points, because those points are very important to us. A prime would be what? 2 comma 1 comma 2. Thank you. 1 comma 2. B. 3, 3, B prime, sorry. C would be, I'm going to refer this second image. Is this a final image? Is this a first pre-image? No. We usually refer to this as their intermediate image. Intermediate meaning the middle image. I'm not going to be like, what did we call the middle image? Okay, it's just going to be, you can call it the middle image. Okay. Now, the second part is telling us to do what to our transformation? By 2. So in this case, it's using the dilation. Dilation we know to be a multiple. In this case, our multiple happens to be 2. So the scale factor is what? 2. Is this going to be an enlargement or a reduction? Enlargement. So we're going to put these right underneath here. This is going to be an enlargement. With scale factor of 2. So we usually do to do a dilation, we usually plot our points out first. Right? So let's go ahead and apply our dilation to it. So A double prime, so we're just going to keep on adding points the more transformations we do. So this similar transformation, what is 2 times 1? 2 times 2. B double prime, 3 times 2. 3 times 2. C double prime, 3 times 2. 3 times 2. Oh, sorry, 2 times 2. Trying to trick you guys over here. Let's plot our points. Over 2 up 4 gives me A double prime. Over 6 up 6 gives me B double prime. Over 6 up 4 gives me C double prime. If I'm going to draw these out and connect them, is it definitely an enlargement? Can we check if we did our dilation correct? The way that we want to describe that is we're going to look at the center origin. In this case, the A lines, the A points stick together from the center of dilation. Do the B's do the same thing? Sure does. And our C does as well. Okay. Your answer is essentially going to be your graph, and it's going to be your final image point. Any image points after we're done. Comprendo? Is this easy or hard? Easy. Okay. Do me a favor, try the second one. We're going to try another one to the right. So we only got 2 more problems. How much more time do we got here? 20 minutes? Should take us. We're good. We're good. Here we go. Do me a favor and try number 2. And I'm actually going to change this one up. So give me a second here. We're going to change this one up to here. I'm going to change this to. So use the same points. Go ahead and plot your points first, and I'm going to fill this in just so we can practice a different one. So let's change that problem up. Let's try our first points. Back to you up 2 is going to be F. Back 2 down 4 is going to be G. Back 4 is going to be H. How about first figure? Got to be able to apply the transformation. What is it asking us to do first? Reflects across the y-axis. So we're going to look at our y-axis line here. The line of reflection happens to be our y line. And we got to be able to reflect it. So it should be its mirror self over. And the way that we did this before is we just counted how far it was away from the line. So 1, 2 would give me F prime. 1, 2 would give me G prime. And then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 would give me H prime. You guys remember doing this? Yeah, kind of, sort of. We're done with that one. Our image is reflected, but we got to be able to write out the points. So let's go ahead and write out the points. What is F prime? 2, 2. What about G prime? Beautiful. H. A bravo. A bravo. Okay, good stuff. We're going to simplify this up. So what is it asking us to do for this second one? By 2. In this case, a dilation is telling me that R is going to be equal to 2. The scale factor of this is going to be 2. Enlargement or reduction? Enlarge. Should be a pretty bigger one, right? So, if we're looking at this, let's enlarge our figure. F double prime, 4 and 4. G double prime, 4 and -8. H double prime. We'll have to go one up our graph, but it's going to be okay. Graph at our points, we're going to go over 4, up 4. That's our F double prime. Over 4, down 8. Mine's going to be a little bit off my graph. And then 8, 8 is going to go G double prime, H double prime. Sorry, mine's a little bit wonky, so let me write it up. Connect your points now. I'll make it a little bit thicker for our final image. Does this hold true? Is it a true dilation? Let's check it. From the center out to F, yes, it works. From the center out to G, yes, it works. From our center out to our H's, it works. Is this easy or hard? Easy. Last and final thing before I give you guys your one problem for your homework, let's look at this next type. We're going to look at, if you'll allow me to, describing the similarity transformations. So can you describe what's happening to this figure? Now, in this case that we're going to do here, the main idea behind this is less is more. Okay? If you can, if it will allow me, give me a second. It's acting funny. In this case, use only 2 transformations. And what I'm really looking for this is you guys got to be able to show me the intermediate transformation, meaning show me the middleman. The middleman is going to be important for you to show me that final picture. Now, is there multiple ways you can do this? Yes. In our cases that we're going to look at, I could slide this up, and then I can reflect it across the axis, and then I can shrink it down to here. The way that we're going to try to do it is we're going to go ahead and reflect it, and then we're going to reduce it. Okay, and that's the image we got to look. Okay. There are multiple ways you can figure these out, but I'm looking just for the verbal explanation as to how we got them and the important information. If we're going from blue, which is PQRS, to trapezoid WXYZ, what's the first indication that I said we were going to do? A reflection. So we're just going to describe it. PQRS is reflected on what axis? On our y-axis. This is our first transformation. Okay. Show me what that reflection on the axis looks like. This is your intermediate step. My y-axis is here to be reflected here. So I'm going to count the spaces over. It's 3 away from Q. Then it is 6 away from P. It is no away from R. And it seems to be 6 away from S. This is what my new figure looks like when I graphed it. Graph all my points here. What's going to help you guys out with the second stage is being able to tell me the center of dilation. It's going from bigger to smaller, so we're definitely having a dilation here. It would help if you put the points through them. X corresponds with my W, or X corresponds with Q. W corresponds with P. Z corresponds with S, and Y corresponds with R. It is definitely a dilation, centered about the origin. So we do want to say that. The second transformation is a dilation. It is definitely a dilation, which is what? Reduction or enlargement? Reduction, getting smaller. By what? We got to be able to find how much it's being reduced by. How do we find, if two pictures are given to us, how do we find out the scale factor between two objects? What do we know the scale factor equation to be? Image over pre-image. So choose one of your points and give me that. Again, use a green point, doesn't matter. Let's say we're going to use X and Q. Let's say we're going to use X and Q here. X's point was 1, 1, right? What was Q's point? 3, 3. So if we use one of the ratios, what is it going to give us? So what's my scale factor? So to simplify this up, it's a dilation reduction by 1/3. Your final answer is going to be the transformation itself. Can you describe to me how did you get that similar transformation? This is what we're going to work on tomorrow and apply to tomorrow. Are we cool with that? How much more time do we got in class? Beautiful. I want you guys to try out this last problem. Can we do that? You guys already have it on your paper, right? Go and do it. That's your homework. That's your homework. Only try to use only 2 transformations, yes. And you have all 4 to use. So you have a rotation, translation, dilation, and reflection. Use those. Okay.